The power feed comes securely packaged in its own box with this foam padding, and this is a double thickness corrugated box, so it should arrive to you without damage. There's also a foam pad that goes over the top here. Inside we have the power supply, power cord for the power supply. This is the travel limit stop switch that mounts onto the table. Here we have the clutch mechanism and some of the hardware for the stop switch, and then the power feed motor unit. I've got the parts laid out here on the bench so you can see there's various mounting screws and then the components. And of course we have a power feed instruction manual for the installation and operations. If you decide to order a power feed for your mill, be sure to get the one that fits the type of mill table that you have. The power feed system has 4 different clutch mechanisms which vary by size. The motor unit is the same for all of them, but the clutch sizes are different. There also may be some minor differences in the installation procedure, but the same installation manual comes with all of the different types and has different sections. So let's go ahead and get to work on the installation. The first step is to remove this end plate from the left end of the table. And use a 5mm hex wrench for that. You can use the hex wrenches that came with the mill, or if you have a T-handle wrench or another one you like better, you might want to use that. Next we have to remove this end plate. Usually these will slide right off. You may need to tap it with a soft hammer or use some screwdrivers down in here if you get a gap started to gently prise it off. Now we can see the slotted end of the lead screw that the power feed engages with. For this next step, the end of the lead screw is going to go into this bushing. I don't know if you can see it on the video, but there's a little raised area like a screwdriver inside of here, and it has to be oriented to match the position of the slot in the lead screw. You want to make sure that the clutch mechanism is in the clockwise position. Now with the knob facing the front of the table, you want to feed the lead screw into that brass bushing and then gently turn the handle on the right end of the table until the two line up. Now the slot is matched up with the little raised area inside there. Now we can get one of the socket head cap screws in place and tighten it just a little bit. Now get the second one in, make sure everything is lined up. Now we can tighten it down snugly. You want to work the X-axis hand wheel in both directions. Make sure there's no binding in the assembly. If there is binding, just loosen up these socket head cap screws a little bit and turn this and then wiggle it a little bit and then gently tighten them again until you find a position where there's minimum binding. You'll notice that the top of the clutch mechanism is slightly lower than the top of the table, and that design is intentional so that if you have a long workpiece, it can extend out over the end of the table. Now we're going to mount the motor unit, but note that there's another shaft here, and that shaft should have a little key in it. If the key's not in there, it may have dropped out in the shipping box, so be sure to inspect the box carefully and make sure you have all the parts before you throw anything away. It's a good idea to keep the box and all the packing materials until you have everything installed and working, just in case something like that came loose in the box. Before you mount the power feed motor unit to the table, note that there's a cable strain relief underneath here, and you really need to run the cable through there before you put this on. On the unit that I got, this is in here very tightly, so you'll need a hefty screwdriver to get it out of there, at least to get it started. You can tighten the screw down because there's still some slack in here. You take up the excess cable so it's less likely to get snagged on anything. So here again we need to get this key engaged with the keyway, so you want to hold this up here, turn the X-axis hand wheel until the two parts line up, and it should drop into place. Now we'll insert these two 4mm screws and tighten them down. I used this little adjustable lab jack to support the weight of the power feed while I was tightening these two screws. But if you just stack some books or whatever you have underneath here to bring it level, that will make it easier to get these two screws tightened in place. This can be awkward to screw into place using a standard Allen wrench or hex wrench, but if you have a set of ball end hex wrenches, this is a great place to use them. Leave this side a little bit loose for now. Now we need to tighten down the 4mm screw on the opposite side. You'll need to adjust the height on the other side to get the screw to fit into the hole. And once you have that lined up, you can just tighten it down. There we go. Okay, now I'll snug this one down. In order to check for binding, we have to turn this knob so that it's pointing upwards or in the counterclockwise position. Then you can turn the X-axis hand wheel and make sure everything still moves smoothly. I'm getting ready to test under power now, and I've got the power brick plugged in. The power brick has a removable cable, which is convenient, but you have to make sure that's in tightly or you may not be getting power. You can tell if it's getting power because this blue LED will be illuminated. And there's no on-off switch, it just stays powered on all the time. It doesn't consume much power unless the motor's actually operating, but you may want to plug the other end of this into a power strip that you can turn off. If you decide to use a power strip for the accessories, you may not want to plug the mill into it because the Bluetooth for the DRO remains powered on all the time. If you unplug the mill or cut off the power to the power plug for the mill, then the Bluetooth will lose power and it'll lose connection with the tablet. So the next time you start up, you'll have to reconnect the two. The DC output end of the power supply has one of these round barrel type connectors, and it connects to a socket on the back of the motor housing. So it's kind of hidden back here on the back side. You want to make sure that's in all the way, and it doesn't actually go all the way in, so it'll stop before it looks like it's fully engaged. You want to make sure this cable's not going to snag on anything as the table's moving left and right, or it may bend or pull out this plug. Before you plug in the power cable to the back, it's a good idea to have this knob in the fully counterclockwise position. There's an on-off switch there. That will help to reduce the possibility of a surge of power coming into the electronics. After confirming that there's no obvious evidence of binding, I'm ready to test the movement of the table with the power feed. Operation is about as simple as it gets. You have the power LED here that shows that the unit is getting power. This fault light will tell you if there's an overload condition. For example, if the table is jammed or binding somehow and creates an overload on the motor current, then it will shut down the motor and turn on this fault light. In that case, you have to turn this all the way to 0 until it clicks, and that will reset it and clear whatever the condition was and try again. So for normal operation, you just turn this up to some speed that you think will be appropriate. After you use it for an hour or two, you'll get a pretty good idea for what speed corresponds to what dial position, and then you either go left or you go right. And then the middle position here is stop. So you can leave your speed setting constant. You don't have to shut this off to change direction, which is nice. And then you can switch directly between left and right movement. So all that remains now is to install the limit switch and the limit end stops. So I'll go ahead and get that done. The limit switch mounts to these two screw holes on the front of the saddle, and it's easiest if you crank the table back a little ways to give yourself some clearance to work. It looks at first as if this little plate here will be in the way of the limit switch, but in fact the back of the limit switch is recessed to allow that to stay in place. Although I guess you do give up the functionality of having that pointer there. I don't think it's too big a deal. You may find it easier to drop one of the screws into place before you put it down here. There's limited space to get your hands in there. And here again, if you have a ball end wrench, you have a little bit more flexibility when working with this. Well, things were going along pretty well, and then I ran into some problems. This little pointer plate is interfering with the mounting of the sensor switch. It looked to me at first as if this raised area was there to provide clearance, but in fact I measured it and this sticks out about 64 thousandths, whereas this raised area is only about 20 thousandths or something. I tried using some 4mm washers under the screws, hoping that would keep the switch out far enough that it wouldn't be a problem, but the washers interfere with the corners of this. So since I have a milling machine, I think what I'm going to do is mill out this area here to provide clearance. The other option would be to remove it, but it's kind of riveted in there, so that seems like it would be kind of a messy job, and someday I might want it there. I'm using the tip on the end of this 4-inch digital caliper to measure the height of that rivet there, and it looks like it's about 76 thousandths above the surface of the saddle. I'm going to call it 78, so I'm going to allow 80 thousandths clearance. Well, I don't know if the rest of you have this problem, but in my shop, it seems like every time I go to do some job that I find another job that has to be done first before the job that I set out to do. The job I set out to do was to mill a slot in the back of the limit switch plate. But before I do that, I need to put the vise back on the table and line up this back jaw so it's parallel. In order to do that, I need a place to mount the base for my dial test indicator. Now on my older 3990 mill, which I donated to a high school, I had a metal plate glued on here, and that was very useful for this sort of thing. So I'm going to put a plate on here just like I did on the other one. I don't have a plate quite as large as I want for right now, so I just found this piece of steel scrap that I'm going to use just to get this job done. I just use a little of this quick grip glue and put it on the back, and then you press it in place. And then the way this stuff works is you kind of peel it off a few times while that glue's setting, and within a few minutes it will be a strong enough bond to hold that magnetic base. You've probably heard me talk in other videos about this quick grip glue, and I get this at the craft store at Walmart, but you can also get it online, I'm sure, at Amazon or elsewhere. But I've been using this for years for all kinds of prototyping purposes where I just want to temporarily bond things to see if things are going to fit properly. It gets tacky and very strong within minutes, but it can be easily removed if you ever want to remove it by just running some denatured alcohol around the joints and letting it seep down behind there. And then you can pry that off, and with a little more denatured alcohol or maybe some naphtha, you can clean off all the residue, and usually it has no effect on the original paint. After a short coffee break, I think I'm ready to mount the dial indicator on there. But first I'm going to use a little bit of denatured alcohol on a gun cleaning patch to clean up some of this glue that oozed out from under the edge there. I'm going to use the power finger to clean up some of this excess glue. If you look on my channel, you should be able to find a video about the power finger. I want to get back to work here, so let's see if we can put the magnetic indicator base on there. And there we go. Pretty sturdy. I can move this around. It's not going anywhere. Now we can get on with lining up the vise. Another nice feature of the power feed is when you need to line the vise up, you can run it down there pretty quickly, see if it's parallel. If you leave one of the bolts a little bit loose, you can tap it with a hammer while it's moving and kind of bring it into zero dynamically. Another nice feature of this power feed is with the clutch mechanism, I can disengage the table from the power feed so that when I use the X-axis hand wheel, it feels just like it did when there was no power feed attached. Let's move to our 0 point. That will be halfway between the two sides. Now I am making an assumption here that these two holes are placed equidistant from the ends of the workpiece. Yeah, and I'm pretty confident that they are. There are two things I wanted to mention. The first is I have the cable wrapped around the vise here to keep it from getting snagged on something. The cable comes out of the back side of this little box that has the micro switches in it, so I couldn't put the box over towards the center of the vise. Therefore, I'm using a little mini shop jack to balance the force over on this side of the vise. The plan is to mill out a slot 0.320 inches high by 0.700 inches wide by 0.080 inches deep. And I'm going to start with the end mill centered at the center of the workpiece, and then I'll use a X-axis offset of 0.153 in either direction. I'm using a 10 millimeter end mill just to make things interesting. If you take 700 minus 10 millimeters, that leaves about 0.306, I guess. And so I'm going to offset 0.153 from center on either side to get the 0.700 width. Hope I got that right. Rather than use an edge finder to find the edge of this workpiece, I'm going to use the end mill itself. And to do that, I'm just going to turn the spindle on very slowly and then gently feed the workpiece forward until I can hear it touching And there it is. So now I've zeroed the y-axis DRO. Next I'm going to zero the z-axis by lowering the end mill down until it makes contact, and then we'll zero the z-axis DRO. And the x-axis DRO is already zeroed on the center. So I'm going to move the end mill out until it clears the edge of the workpiece. Now I'll lower the z-axis down to a depth of 60,000th, I think. Our final depth will be 80. I'll save the final depth for a finishing pass. Okay, I'm watching the z-axis DRO. I now have it at 0.060 deep. So I'll lock the z-axis so it can't move downward. And then we'll turn on the mill. I'm going to go with about 1,000 RPM. Now I'm going to offset 140 thousandths to the left. Lock the x-axis. Now we'll make a cut in the y-axis, 0.320 long. Okay, there we are. Alright. Here's the slot after taking it to full width and depth using the 10mm end mill. Now I'm going to go into these corners with a 4mm end mill to reduce the radius so that the scale will fit up in there better. And there's our finished slot, so let's get it in place and see if it works. Okay, our milled slot looks like it's about right. So if everything comes together, that hopefully will fit right in there. Well, it turned out it didn't fit. The slot is actually the right size. It just happens to be in the wrong location. It was probably obvious to those of you who are paying attention that the bottom of this slot has to be up above the top of the screws. Of course, I made it down here somewhere, so I need to cut the slot further up. Well, there's a look at our new enlarged slot, and I actually already tested it, and it does fit this time. I used a small abrasive stone to go around these sharp edges here to remove any burrs. Now we have a nice snug fit, and there's a very small gap between the back of the box and the front edge of the table, so that the table can move freely without rubbing against that. The cables that come with the power feed are really longer than necessary, so I bundled up the excess and used a cable clamp to hold them all in place. So I have the limit switch in place now. There's a button on either side of the limit switch that triggers a micro switch inside and stops the motion when the table is gone as far as it can go in that direction. So let's take a look at that in action. To back it off of the stop, you can just reverse the switch. On my mill, I like to position these as far at either end of the table as they can go. That gives you the maximum amount of table movement between the two stops. This socket head cap screw is not the type that came with this stop, but in my kit of parts apparently there was a screw missing, or I dropped one and lost it when I was opening the bag. The screw and nut that came with the stop looked like this. I removed this one and replaced both of them with standard 4mm socket head cap screws. When you go to install the end stops, note that there's two different orientations that are possible. If you have it in the upper position, the stop rod won't match up with the height of the button on the stop switch. Since I'm now just using the standard nut on the back side, while I was tightening the socket head cap screw, I had to maintain some outward pressure on the stop to prevent the nut from turning back inside of there. Another interesting feature of the DRO is that if you go to the x-axis display, and this little message will get out of the way in a second, it has a feed rate feature, and as I turn on the power feed, it'll tell me how fast it's going. So I'll turn the speed way down, and the minus sign means it's going to the left. So if I switch it to the right, and of course if you go out here and you change from inch units to metric units, then when you go back in, the feed rate's in millimeters per minute instead of inches per minute. So I don't see too much value of that for most ordinary work that I do, but one place where it could be useful, when I do production type work or under contract, a lot of times I make multiple prototypes before I get the process figured out. So it might be something that would be useful to record in my shop notebook as I'm experimenting with different feeds and speeds and so forth. I'm ready now to run a real test of the power feed. You may remember this workpiece from earlier in the video series, and I chose it because it's just about at the maximum length that the mini mill can handle in one pass. So with the end mill just a little bit to the left of the end of the workpiece, we're already pretty much up against the stop, but the table will be moving away from the stop to the left. I very lightly touched off the end mill against the surface here and then zeroed my y-axis. And of course, since we're going to be cutting on the side of the workpiece, I have the z-axis down a little bit below the bottom of the work here. The table will be moving to the left, so we'll be moving into the cutter. That will be conventional milling for our initial pass, and then I'll do a climb milling pass on the way back. And I'm going to start out with a pretty low feed rate. I may adjust it as we get into the cut and see how things are going. Well, that's not working because I've got the camera mounted on the table and I'm getting a lot of vibration. All right, let's try that again. I'm going to go with about 1200 RPM. We were just about at the stop, so I let it go ahead and run into the stop, and as you can see, it did its job. I was getting some rattle from this roller handle on the x-axis hand wheel, so I'm going to try putting a little grease on there, see if that will get rid of that noise. I put some silicone grease on the shaft for that handle. Hopefully that will eliminate some of the rattling sound. For the return pass, the workpiece will be moving from left to right, so we'll be doing climb milling. I'm just going to take a light cut of about 2/1000, and I'm going to run at about 2000 RPM since we'll be taking a very light cut, and I'll feed slowly to give us a nice surface finish. Well, that wraps up my review of the power feed option. Thanks for tuning in, and we'll see you next time.